All right, everybody, I recorded this whole video just a second ago and then realized my microphone was turned off, so the audio didn't capture. So I'm just going to watch the video here and then just kind of talk over it, and hopefully this will all look the same to you guys by the time we got done. So in 11.5, we're talking here about the volume of pyramids and cones. And so let's start working on this first problem right here. Most people are able to recognize this figure pretty quickly as a pyramid. Kind of the telltale sign is that purple dot at the top, that everything here comes to one particular point up above. So if we recognize that as a pyramid, let's get working on this. Our formula for volume of a pyramid here is going to be 1/3 times capital B times H. Capital B still means area of the base, and H still means height of the solid. And that can be a little bit tricky to figure out in certain problems, but we'll come back to that a little bit later and talk about what exactly that means. So step 2, let's fill in what we know here. All right, so volume is equal to, we've got our 1/3 here. We're going to have to figure out the area of the base and our height. Now, in this particular shape that we have right over here, this one isn't too tough to figure out. For capital B, for area of the base, we need to look at what's down on the bottom end of this figure, and this one's pretty quick to see. We've got 4 sides, which makes it a quadrilateral. There are 4 right angles there, which makes it a rectangle, and in these 2 sides, the 5 and 5 being adjacent to each other, we can see that this rectangle is actually a square. So for the area of that square base, it's going to be 5 yards times 5 yards, which is going to get us 25 square yards, technically, for the area of that base. You don't have to put the units there, but I like to talk about that, and you'll see why in a second. Okay, now let's move on to finding H. The height of the pyramid can be a little bit tricky to find in some cases, but I think on this worksheet they made it pretty easy for you. If we're going to talk about the height of a pyramid, what we really need to do is take a moment to talk about what cursive L meant, which was the slant height that we talked about earlier in this chapter. So actually, I'm going to switch to green here for just a second, and let's talk about slant height in green. When we were finding surface area in section 11.3, we learned that that green segment right there, which goes from the point on the top of a pyramid to the midpoint of one of your sides, that's called your slant height, and that's necessary in order to figure out surface area. But when we're doing volume, the actual height of a pyramid is a line segment that runs from the very peak of the pyramid inside the pyramid, and it goes all the way down to the exact center of the base. So if you were standing outside of one of these pyramids in Egypt, you'd be able to see a slant height because it's on the outside of the figure, but the height itself would be inside. And they were nice enough to give us the height right here of 9 yards. So we'll go back to our formula here and put in 9 yards for the height, and now we're pretty much ready to go. So let me switch back to purple right here, and we'll multiply everything out. Now, most of you guys would probably grab a calculator right here, but you really don't need to in a problem like this. We caught a break right here. Some problems here with pyramids will work out nicely, and this one does. And the reason is because one of the 2 numbers that we came up with, either the 25 or the 9, is a multiple of 3. And when we have a 1/3 out in front of our formula, we're really dividing by 3. So what's going to happen here is that 9 yards in red gets divided by 3 to give us 3. We multiply the 3 by 25 and we get 75. Now for units here, we've got square yards for area of the base, linear yards for the height, and square yards times linear yards is going to get us cubic yards. So there's our answer for number 1. The volume of that square pyramid is 75 cubic yards. Okay, the next, 5 problems after that are just more square pyramids and rectangular pyramids, but I wanted to do one here with you. This is a shape that bothers people just a little bit. We recognize it as a pyramid because of that peak on the top, but we've got 3 sides that make up the base there. And remembering that pyramids are named by the shape of their base, what we have right here is a triangular pyramid. Now that can confuse people just a little bit because a lot of people want to say, wait a minute, aren't all pyramids triangular? Well, no. All pyramids do contain triangles. But let's look back at this pyramid that we were dealing with in problem number 1. Let me erase all that junk that I had in the way here. What you see here is that this pyramid has 4 triangles going around the sides, meeting at the point. But pyramids are named by the shape of their base. The base in number 1 was a square, and that's why this is called a square pyramid. But if we go back to what's going on in number 7, our base is a triangle there. So this is what's called a triangular pyramid. In addition to the triangles on the side, it also has a triangle for its base. Same formula now. Volume of a pyramid is 1/3 area of the base times the height. So let's fill in what we know, but not much yet. So 1/3, we'll need area of the base, and we'll need height. Let's get working on area of the base first. And finding the area of a triangle is a little bit more difficult than finding the area of a square, which we did in the last problem. So to find capital B, the area of this triangle down here on the bottom, we need the formula for area of a triangle, which is hopefully one you guys have memorized by now. The important thing here, though, guys, is that there's a right angle in that corner. So this isn't just any triangle there in blue, it's a right triangle. So that formula that we need here, right here for the area of a triangle is, there we go, 1/2 times the base of that triangle times the height of that triangle. And remember a big concept from chapter 10, base and height of any figure have to be perpendicular. So the significance of having a right triangle down there on the bottom is that the 2 legs, the 6 meter and the 8 meter sides, because they're perpendicular to each other, those can be used for your base and your height, and it doesn't matter which one goes where. So the 6 times 8 gets us 48, half of that is 24. So the area of that blue triangle right down here on the bottom is 24 square meters. So we'll put that in there for capital B, and we'll go on our merry way. All right, let me switch to red here. And now we need to come up with H, which is the height of the pyramid, which again is a line segment that goes from the peak to the center of the base. And once again, they were nice enough just to tell us that that height had a length of 11 meters. So we know capital B, we know H, let's figure this all out. Now we caught a break here yet again, just like we did in the last problem. If you look at the 2 numbers we wrote in, 24, not the 11, but 24 is divisible by 3. So we would do 1/3 of the 24, which is 8, and the 8 times the 11 meter height is going to get us 88. Square meters times linear meters is going to get us cubic meters for our units of volume. So there's number 7, 88 cubic meters for the volume of that one. Okay, 9 through 12 are a little bit harder here, guys. Once again, we're dealing with a pyramid. We see the peak up on the top, but let's look at the bottom of this figure. 1, 2, 3, 4, 5 vertices make up the bottom. That means that the base is a pentagon, so we would call this particular shape here a pentagonal pyramid. Okay, pyramid because it comes to a peak up on the top, pentagonal because its base is a pentagon. Same formula now. Volume of a pyramid is still 1/3 times the area of its base times its height. We don't know very much right now, so we'll just kind of draw the general framework of what's going on here with some blank parentheses for capital B and for H, and let's get to work. Okay, so to find the area of our base is a pentagon, and because of the tick marks on the 5 sides on the base, we know that this pentagon is a regular pentagon. So to find the area of our base, we need the formula that we learned in chapter 10 for area of a regular polygon, which hopefully we recall is 1/2 times the perimeter of that polygon multiplied by its apothem. So let's fill in what we know. To find perimeter, let's take a look at our base. 5 sides with tick marks, so they're all congruent, and each one of them is 8 yards. 5 times 8 is going to get us a perimeter of 40 yards, and that's capital P. A is apothem. An apothem, if you recall, is a segment that goes from the center of a regular polygon to the midpoint of one of its sides. There's your apothem, and they were nice enough here to give you that as 5.5 yards right underneath it there. So 5.5 is our apothem, and we need to do 1/2 times 40 times 5.5 in order to figure out now what the area of our base is. So that's one we'd probably do on a calculator. I'd find a way to make this look a little better. So I'm going to type in 0.5 times 40 times 5.5, and we got 110 for the area of that base. Okay, so that's that, and now we know what to put in this first blank set of parentheses down here, 110, and that would be square yards because it's an area. Okay, switching to red, height, again, is a segment that goes from the peak of the pyramid straight down to the center of the base, and that's 10 yards. Now, we did not get as lucky in this problem as we did in the previous two. Neither the 110 nor the 10 is evenly divisible by 3, and that means, everybody, that we're going to end up with a decimal for this answer. But I want to take just a second and talk about something really important here. In a lot of previous problems, you guys have watched me here go to the calculator, kind of like the computation I just did that you're looking at above my line now, and where I had a 1/2 written down on my paper, I would type in a 0.5 in my calculator. Two reasons. Number one, it's faster and easier to type in 0.5, but the reason we're allowed to do it, this is what's important, is that 1/2 is exactly equal to 0.5. The problem comes right now, and in some stuff we're going to do later in this chapter, when we need to do a 1/3, and 1/3 does not compute nicely as a decimal. I've seen a lot of people make the mistake of just typing in 0.3 or 0.33, but those are decimal approximations that are not exactly equal to 1/3. So anytime we have a 1/3 here, I'm going to go ahead and use my fraction key and type it in as 1/3. If you didn't have a fraction key, you could just type in 1 divided by 3, and that would work too. So here's 1/3 times the area of our base here, which was 110. And then we're going to multiply that times our height of this pyramid, which was 10. I believe that's right. And yeah, just double checking everything there. That all looks correct. So our volume of this pyramid now is 366.6 repeating. This is where you really want to check your directions and find out what's going on for sure. So if I go, let's see, all the way back to number 1, find the volume of each figure. Yep, round your answers to the nearest hundredth. We're going to go with 366.6, and then that second 6 rounds up to a 7. So 366.67 square yards times linear yards gets us cubic yards for the volume of this pyramid here in number 9. 10, 11, and 12 are the same pretty much. I think 11 and 12 have hexagonal pyramids, but you'll get the gist of that. All right, and I wanted to do one problem like this with you guys. This is a cone. Again, most people recognize it. Peak up on the top, just like a pyramid. But unlike a pyramid, which has a polygon for its base, in a cone, your base is a circle. So a circle on the bottom coming up to a point at the top, that's the definition of a cone. And the formula here for volume of a cone really is exactly the same as the formula for the volume of a pyramid, even though people don't often recognize it. Let's see why. So volume of a cone is going to be 1/3 multiplied by pi r squared times h. Now let's compare that to the formula for volume of a pyramid that we used on the last 3 problems. That was 1/3 capital B times h. So what's the same right here? Well, we can see they both have a 1/3 out in front. They both have an h for height at the end. The difference is that the pyramid formula uses a capital B for area of the base, and in a cone that becomes pi r squared. That's because in a cone, your base is always known to be a circle, and the area of your base then can always be found by the formula for area of a circle, which is pi r squared. So they really are one and the same formula here. Okay, so knowing that, let's see what we can fill in right here on step 2. All right, so volume is equal to 1/3 times a pi. We need our radius, and don't forget to square that, multiplied by our height. Now, the one thing that's tricky about this problem is that 4 centimeter segment that they gave you down on the bottom spans from the left edge to the right edge of that circular base, which means 4 is not your radius, 4 is your entire diameter. So to find the radius, we just need to cut that 4 in half, and that's going to get us 2 centimeters then for the radius of that circular base. And then for the height of the entire pyramid, again, they gave that to you right here. From the peak straight down to the center of the bottom, 6 centimeters is going to be your height. Now here, this one doesn't work out all that badly, guys. We could do this one without a calculator. Let's see how we might do that. The first thing we'd have to do by order of operations is to take the 2 centimeters and square that. We got to do exponents first here. And we're not going to put the pi into our calculator now. You'll see what that looks like in a second. So we're going to take 2 centimeters and square that to get 4 square centimeters. There we go. So the 2 gets squared to make a 4. We'd multiply the 4 times 6 to get 24. And then to take 1/3 of 24, we're just dividing 24 by 3. That's how we're going to end up with an 8 for the coefficient of our answer. The pi just tags along. And then looking at units, we have, this is going to be a little tricky, centimeters got squared to make square centimeters times linear centimeters, and there's cubic centimeters yet again. And that's all we want to do with that answer, guys. Okay, so that's a wrap on number 13. I think 14 through 16 should work about the same. So give the rest of that assignment a try, and let's see how it goes, and let me know if you guys have any questions.